and welcome to my presentation. My name is Thomas Preisner and I'm working in the SILIKA project on narrow beam base station systems for millimeter wave mobile communications. Narrow beam antenna systems can be realized in multiple ways. For example, we can use multiple antenna elements as a phased array to generate a beam in a certain direction. Another way is to use a phased array fed reflector, where we use a smaller array to illuminate a reflector which results in a high gain beam. Or we use directly high gain antennas, like horn antennas, to generate a beam with a high gain in a certain direction. In all those cases, we have one common problem. We do not know where to point our beam, since this depends on the user's position as well as on the scenario. There are multiple solutions, like a channel estimation, as well as an SNR comparison by doing a scan or using a fixed beam solution. Another question is if we have actually an advantage by using narrow beam antenna systems, and therefore I looked into different scenarios with different antenna beams. The positive outcome of both studies allowed me to look into how to realize narrow beam antenna systems. Therefore, I performed a system-level study on a fixed beam solution. The interest of the study was to find out the best beam distribution. That means for a certain scenario, I wanted to figure out how many beams do I need? What kind of shape do they have to provide full coverage? And how many different shapes do I actually need? Those questions I have answered with that study, and based on that, I have realized those antennas in CST. Due to the high gain that is needed, it was decided to use a lens horn antenna. The horn shape gives a high gain, and by using a lens, the horn becomes actually compact. This antenna system was then realized and measured. Currently, we are using the measured and simulated radiation pattern for an interference study. I hope this video gave you some insight into the SILIKA, and I want to say a special thanks to the European Union that made this project possible. And if you're looking for a PhD position, I can encourage you to also look for a European project.